Okay, more problems from 6.4. This is number 5, another differential equation with initial conditions. Y equals 1 when x equals 0. So again, we just separate our variables. So we put the y plus 5, divide both sides by y plus 5. So we got dy over y plus 5 and multiply by dx. And we've got x plus 2 dx. Then I take the antiderivative of both sides. And then the antiderivative of 1 over y plus 5 is the natural log of the absolute value of y plus 5. And that's going to be the antiderivative of x plus 2 dx. So that's going to be x squared over 2 plus 2x plus c. And again, that's going to be the natural log, 1 over u du. The derivative, that's just 1, so that's going to be that. Okay, again, I write it as an exponential equation. This is my base e, this is my exponent. So e to the x squared over 2 plus 2x plus c equals y plus 5, and that's going to have to be positive, because that's always positive, so we don't need the absolute value on that. And we can kind of reverse and say y plus 5 equals this. And what I can do is I can break this up into e to the x squared over 2 plus 2x times e to the c. I just would break it up from an addition here to a multiplication, using my properties of exponents. And e to the c is just another constant, so that's just c. And then I can put this in front when I rewrite this down here. So I have y plus 5 equals c times e to the x squared over 2 plus 2x. And then I can subtract 5 from both sides. So I've got y equals c, e to the x squared over 2 plus 2x power, this is a power, minus 5. Now I know y equals 1 when x equals 0, so I can put this into this equation. So I put 1 for the y, and this is going to be c, e to the, and x is 0, so that's going to be x squared over 2, 0 squared over 2, plus 2 times 0, 2 times x, 2 times 0, minus 5. Well, that's just 0, because 0 squared, that's going to be 0 over 2, plus 2 times 0 is 0, it's just 0. What's e to the 0 power? 1. So I've got 1 times c minus 5. If I add 5 to both sides, I end up with c equals 6. So I just substitute that in my equation. I don't have any natural logs of x or any issues like this, so my domain would be all real numbers, negative infinity to infinity. When I put the 6 back in here, I've got y equals 6 e to the x squared over 2 plus 2x power minus 5. So there's your solution. Okay, hope that all works out. Okay, number 7. So dy dx equals the cosine of x times e to the y plus sine of x. So this might throw you a little bit because we've got y and x all up here with e, but we can just break this up and do a product. Cosine of x, e to the y times e to the sine of x. So just break that up. And now we can separate the variables. So over here with the dy, what I'm going to do is I'm going to divide by the e to the y, both sides, and that leaves me with the cosine of x e to the sine of x, and I'll write that e to the sine of x times this cosine of x, and I put the dx up here. So then we'll take the antiderivative of both sides, or the integral of both sides. And I can write this as e to the negative y dy. And again, this would be e to the sine x cosine of x. Now, the antiderivative of e to the u is e to the u du. So I just need the antiderivative of e to the u du is just e to the u. So I need to have this du over here. So in this case, my u is negative y. So the du would be negative dy. So I need a negative sign here. Well, I could put a negative here and I could put a negative in front. So it's kind of like an abbreviated u substitution. All right? Put this up a little bit. Okay, so I adjust this, so we doctor this up. So we have an e to the u du, but if I put a negative sign here, I've got to put a negative sign out in front, because in essence it's negative times negative, which is a positive. And this is all set up because this looks like this is Also e to the u du, and I've got the derivative of the sine of x is cosine of x dx. So this is all set up. So the antiderivative of e to the u du is just e to the u, so that's going to be e to the minus y. That's what u is, with this negative that I had to put over here to adjust this. And that equals, and this is going to be e to the u du, so that's just going to be e to the u, which is e to the sine of x plus c. Okay. And then I've got my initial condition over here. I know y equals 0 when x equals 0, so I'll put a 0 in for the y and a 0 in for the x. Well, e to the negative 0 is like e to the 0, which is 1, so I've got negative 1 on the left. What's the sine of 0? Well, the sine of 0 is 0. E to the 0 is, again, 1. And then if I subtract 1 from both sides, I have c equals negative 2. So the negative 2 goes here. So I've got negative e to the negative y, sine e to the sine of x minus 2. And I can make this positive, so I could just multiply by negative 1, both sides. And that ends up making this positive e to the negative y equals positive 2 minus e to the sine x. Now we want to solve for y. So I'll take the natural log of both sides to do that, because I want to get this y down on a level, so I have to use the natural log to get it down. It's an exponential equation. I'm going to solve for the y. So the natural log of e to the y equals the natural log of 2 minus e sine of x. So what I can do now is I can use the property of logarithms, and I can put this in front. So I move my negative y, my exponent in front, times the natural log of e equals the same thing over here, the natural log of 2 minus e sine of x. Let me move this over a little bit. Okay. What's the natural log of e? The natural log of e is 1, so that just is absorbed. So I've got negative y equals the natural log of 2 minus e sine of x. So I want to solve for positive y, so I multiply both sides by a negative 1, so I get y equals negative the natural log of 2 minus e to the sine of x. And I don't have any natural log of x or anything like that that would put a restriction on x, so my domain would be negative infinity to infinity. Okay? So I hope those all make sense.